Hey guys, welcome to our today's tutorial, pharmaceutical chemistry and analysis. And we are going to look at benzene chemistry. Remember, that's where we are. And the electrophilic aromatic substitution reaction. Last time we looked at the nitration reaction, which is electrophilic substitution reaction of benzene. Today we are going to look at the other reaction that a benzene undergo under the electrophilic substitution reaction, electrophilic aromatic substitution reaction. This is what is known as sulfonation. Remember, we are on part 6 of benzene chemistry. So sulfonation, we need to know how to write the mechanism. Sulfonation is when a benzene, so this is our benzene, react with sulfur trioxide and sulfuric acid to give us this. Okay. Alright, so this is the general equation of sulfonation, but what we need is to know how to write the mechanism. Remember, the steps that are involved in electrophilic aromatic substitution reaction are just 3 and they are the same. So even here, we are going to look at those 3 steps, then we are done. The first step is generation of an electrophile. So we need to generate an electrophile. This is an electrophile which is added here. This is an electrophile which is added there. So now, how can we generate this electrophile from this? So they say propose a reasonable mechanism for this reaction. What we need is just to propose the reasonable mechanism. As long as that reaction or that mechanism that you are proposing is reasonable or is appropriate, we are going to use that. So the first step is to generate an electrophile. So what are we going to do? Let's try to generate an electrophile. So here we're going to get this, which is we're going to get this sulfur trioxide, which will be like this. Okay, even the electrons there. Okay, like that. Then we are going to get sulfuric acid. Sulfuric acid, we can write it like this. Okay, that is sulfuric acid. Then what we are going to do, we want to generate an electrophile. For us to generate an electrophile here, this is what we are going to do. One bond, here you see it's a double bond that attaches to the oxygen. One bond here will open. When it opens, you know that when it opens, it will leave this oxygen to have negative or electron. So here, one bond will open and come and attack this hydrogen. Then all the electrons here will come direct to the oxygen there. So what we are trying to have here is to grab this hydrogen, and here we are going to have this. We're going to have this like this here, something like this. Plus, when you get one hydrogen, if it has lost hydrogen there, it's going to have to be like this, which will be the base at that particular time. You get? Then here we are going to have positive like that. You see? Then I can even include the electrons here. Okay, something like that. So now, here this, what I've produced here, that is an electrophile. So here, I'm just going to say this is an electrophile. That is the one that I have generated. This is an electrophile. You get? So the second step is now, we said this is the benzene. Okay, this is the benzene. The first step we say 1 pi bond of a benzene ring will attach 1 pi bond of a benzene ring will attach an electrophile. 1 pi bond of a benzene will attach an electrophile. You see, like that. Then we are going to have the non-aromatic carbonation, which is called uranium ion. So this electrophile which I have is also known as sulfonium ion. Sulfonium ion, that is this which is we have here, the one which we have here, an electrophile. So when a pi bond of a benzene ring attaches the electrophile, we are going to have the uranium ion, which is non-aromatic carbonation. So this is what I'm going to write here, like this. So here it will be like this, then here I can even write, here it has got how many oxygen? 1, 2, 3, like this. So it will be like this. Okay, something like that. Right, so when I reach there, I can write the resonance form or uranium resonance for me to have a stable transitional state or to promote the forward reaction to be favored. So here, I'm going to do, here there is a positive here, you see, because one bond has broken and attaches to the electrophile. So here, the bond is the one which has attaches to an electrophile, and here I'm going to have positive. That's what we learned. So for me to stabilize this bond can break and come here or can shift there. Then what am I going to have? I'm going to have this, like this, this. Then where am I going to have a positive? It's like this. Also, I can stabilize this charge by breaking the bond and come here. What am I going to have? I'm going to have this. So here the bond will be here, here will be there, then positive will be there, which is next to an electrophile, like this. Then I can put them in brackets. These are called uranium resonance. After that, I can go to the step number 3. Step number 3. So here, step 3. Step 3, we said these uranium ion are non-aromatic carbonation. For us to get it back to benzene ring, we need to restore it by this to lose a proton on the carbon that bears an electrophile, and that bond will come and make a pi or a double bond inside to make a pi, and it will get back to a benzene ring. So the last step is restoration of a benzene ring, which is like this. So looking at the product that we have here, it's exactly the same as it is like that. So we'll just choose the uranium. These are the same uranium ion or resonance ion resonance, our uranium resonance. We are going to find that this is exactly that we are going to get with a positive here. Then here there's a bond, here there's a bond, like that. Then we are going just to expose the hydrogen, because this one has to be lost on the carbon that bears an electrophile. So let me get the base now. The base that I'm going to have is this one, which is after generating an electrophile when hydrogen was lost on the acid, which is sulfuric acid, we have this. So here I can just write it here like this. Okay, with the negative there. So this one will come and get this hydrogen, and this bond will come and make a double bond there. I'm sure you can see this hydrogen has been grabbed and this bond has come to make a double bond there. Then what are we going to have? We are going to have something like this. Here there is double bond, here double bond, and here double bond. Then here we are going to have this like that, the way it is. Then plus the acid. Now you can see that here we have gotten the hydrogen and it has become now two like this. So this is the acid that we are going to have. Okay, like this. Then the reaction is done. The first step, generation of an electrophile. This bond will come and get, this one will open and come and get this hydrogen. This one will do, all the electrons will go direct to the oxygen. Then we have this, which is a base. Then this is an electrophile which have generated, which is also known as sulfonium ion. Then here this the step 2, we said this the pi bond of a benzene ring will attach itself to the electrophile. Then what will happen is that we are going to have non-aromatic carbonation, which is called uranium ion. So then we form uranium resonance by saying this one for this charge to be stabilized, this bond will shift here and will be like this. Then also the bond will be, or the charge will be here. So for this charge to be stabilized, this bond will shift here, the charge will be on top next to the electrophile. Then we are good to go. Then this one, step 3, we said we need to restore the benzene. Since this one is non-aromatic carbonation, but we need to restore the aromatic benzene ring. Then the hydrogen on the carbon that bears an electrophile has to be lost in order for us to get the to get it back to the benzene ring. So when the hydrogen is lost, then the bond will come and will come and make a double bond there. That's what we did. So I've gotten this one, which is this, which I've gotten. That's this exactly, because we wanted to have exactly product that we have there. This, you get? So you see, so here the hydrogen has been grabbed, then the bond, make the double bond there, pi, then have this product. And this is exactly the product that we have, plus acid, because you have added hydrogen there. So this is just sulfonation reaction, which is electrophilic aromatic substitution reaction. Thank you so much, guys, for watching this video. Please subscribe for more videos.